So the next problem on CodeChef is largest k. In this problem, we'll be given x and y, and we have to find the largest integer k such a way that we have to find a number which has zero number of x's, one number of y's in it, and it has at least k ones between any two zeros in that binary string. So the input format for this problem is we will be given the number of test cases t, and each test case will have x and y. And output format will be to print the largest integer k possible using x and y. Constraints for this problem are t can tend up to 10 to the power 5, and x and y individually can start from 2 till 10 to the power of 9.
So let's get on to the approach of the problem. Yeah. So let's start by looking at the sample test cases. So we have x as the number of zeros, y as the number of ones. Suppose let's take the first test case. X should be 2, y should be 10. So we can have 2 zeros and we can have 10 ones. Okay? Yeah. So let's start placing them. Let's see how we can do it. One thing we can do is 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7. This can be one way. But just a second, we've been asked that we have to find the largest k, such that there are at least k ones between any two occurrences. So between two occurrences, there should be at least, or any two occurrences of zero, there should be at least k ones. Okay, and we have to find such largest k. So here we have two occurrences of zeros, right? So between both of them, we should have k ones. We have here 1, 1, 2, 3, 4, 5, 6, 7. You have 7 ones. So your k will be 7, but just a second. K can be greater than 7, right? Let's try this approach this way. 1, 2, 3. If we place it this way, then we can have 10 k's. So yeah, 10 will be the largest number. Yeah, so 10 k can be 10. So yeah, we have our answer as 10. And as largest k can be 10. Okay. Let's see for the next. Let's see for the next test case. Let's get on this one. Yeah. So moving on to the next test case. It's given 3 and 2. We have 3 zeros and 2 ones. So one way to place it would be 1, 1, 0, 0, 0. But here k will become 0. As between these two occurrences, there's no 1. Between these two occurrences, there's no 1. So at least there are 0 ones between any two occurrences of 0. So this case will be 0. A better way to place it would be this, I suppose, as this is giving us k as 1. This thing, k as 1. Okay, as between any two occurrences, there's at least 1. And I don't think, like, as we can see, there's no greater value of k possible. So k will be 1. But instead of doing all this manual stuff, one thing we can do is, if we see, if there are x zeros, suppose let's x is equal to 4, suppose there are 4 zeros. So for k to be 1, in this case, there should be 1, 1, 1, these 3 ones present, so that between any two occurrences of 0, there's at least 1, 1. So for this to happen, for x zeros, we need to have, like, y should be, number of 1 should be 3, which is basically x minus 1. For this to be 2, for k to be 2, there should be at least 2 ones present, where this should be basically 6. Like, this should be basically 6, which is 2 into x minus 1. So let's see, can we reduce this into a formula? The formula, suppose if I write this way, the answer is equals to y is basically the number of ones, by x minus 1. Okay, x is the number of zeros. Let's see if this works or not. So for our sample test case, we can see when x is 3 and y is 2. Okay, we put it over here. Y is 2, x is 3 minus 1, which is 2 by 2. This gives us 1. And as we can see through the placement, this is the best placement we can have where k is 1. So yeah, the formula works. For the next one, let's try. Next one, y we have 10, sorry, y we have 5, and x we have 10. So 5 by 10 minus 1, which is 5 by 9, and as our division takes only integral part, so this will be 0. Let's see for this by placing this. We have 10 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We start placing 1, we have 5 ones. 1, 2, 3, 4, 5. Now we can't place any more ones. Between these two zeros, these two zeros, there's no 1. So k will be 0 over here, which according to a formula we're getting right. The formula basically is deduced from if you place like zeros and if you want to place 1 between them. So if k should be like at least 1 should be between every 0. So there should be, like suppose there is 0, there should be x minus 1 ones. If 2 1 should be present between each of them, so there should be 2 into x minus 1. And if a number of ones, which is y, is between 2 into x minus 1 and x minus 1, then the number of then k will be the lesser one. Like then k will be 1 basically. As suppose let's take an example. We have 4 zeros and k we have as, suppose let's take 3. Not 3. Let's take it as 5. Let's take y as 5, which is basically less than, like suppose 2 into x is, just a second, x is 4, right? So x is basically 4, so we can say 2 into 4 minus 1, which is basically 3 into 2, which is 6. At least we require to reach 2. Right now we have 5, so let's see we can reach 2 through 5. So we place 1 over here. Now k will be 1. Now we have 2 left. We place 1 over here and 1 over here. So here there is two occurrence of 0, between which there is only 1 non present. So answer will be 1 only. So as said above, uh, for k to be 2 should be at least 2 into x minus 1, and for k to be n, it should be at least, it should be at least n into x minus 1. So hence the formula works. Answer is equals to y by x minus 1. So we can use this formula to simply get the largest number of k, such that between any two occurrences of 0, there is at least k number of ones. So yeah, we're done. And yeah, about the time complexity, as we are using a mathematical formula, so time complexity is 1 for each test case, and space complexity is also 1.